This is my Hawks problems that I got when I did the practice. So letter A, I have x to the fourth times x to the negative first. So I'm just going to use my rule for multiplying two numbers that have the same base, which says to add their exponents. So 4 plus negative 1 is positive 3. So there's that one. All right, letter B says x to the sixth divided by x to the first. Well, the quotient rule just says to subtract the exponents. So 6 minus 1 is 5. Letter C says simplify using only positive exponents. So right now that's written so that the x is in the numerator. So in order to make my exponent positive, I'm going to flip it over the line. So I'm going to flip it down to the denominator. I can't have a blank on top, so I have to put a 1 there. So it's 1 over x to the sixth. Letter D, I'm going to divide my coefficients. So negative 15 divided by negative 3 is positive 5. I have 6x on the top, 5x's on the bottom. I would cancel out pairs, and I would have 1x left on the top. Or in other words, if I subtract, 6 minus 5 is positive 1. So I would have 1x on the top, and x to the first is just x. So that's my answer simplified. All right, this is still practice problems for Hawks. On this particular problem, this is a multiplication problem. So I'm going to multiply my two coefficients. So 2 times negative 6 is negative 12. I'm going to multiply two numbers that have the same base, the x's, which means I'm going to add their exponents. So negative 3 plus negative 5 is negative 8. I'm going to add negative 2 and negative 1 and get negative 3. That's not simplified because I can't have negative exponents. So my negative 12 is a whole number and it goes over 1, so it stays in the numerator. My x gets dropped to the denominator because I have a negative 8. So I drop it over the line, change the sign. Same thing with y. Y to the negative third is the same thing as 1 over y to the third. And now I have simplified that whole thing. Now it's okay if this number has a negative and it's in the top because that's a coefficient. That's not a negative exponent. Only negative exponents get flipped over the line. Letter F, it's been multiplied basically. I have this two numbers that have the same base. This time the negative 2 is not a coefficient, it is a base. And they have, it's two numbers being multiplied that have the same base. So I bring down my base as part of my answer. And the rule for the product rule is to add the exponents. So negative 2 to the 6th power. I'm not sure what that is, so I'm going to plug it into my calculator. Negative 2 raised to the 6th power. And my answer is 64. Or I could have just typed that exactly the way I see it in my calculator and it would have given me my answer. Letter G, I have 5 to the 5th divided by 5 to the 4th. My 5s are now the bases because they both have exponents. So I don't divide 5 and 5. They're not coefficients, they're bases. And 5 minus 4 is 1. So this would be equal to 5 to the 1st, and 5 to the 1st is just 5. Letter H, it wants me to simplify it so that I only have positive exponents. Well, the 3 is a coefficient, and it is a whole number 3. I could rewrite that 3 over 1. So when I'm simplifying that, I keep my 3 in my numerator. The x is raised to a negative exponent, so I'm going to flip it down to the bottom and let my negative sign go away. Same thing with y. It has a negative exponent. The only way to make it positive is to flip it below the line. And so that is my answer, simplified. And letter I, any number raised to a 0 power is 1. So x to the 0 is 1 minus 2 times y to the 0 power. Well, y to the 0 power is 1. So 1 minus 2 times 1 is 2. Well, 1 minus 2 is negative 1. And that's my answer. So remember, this is a multiplication problem. This is 2 times y to the 0. Y to the 0 is 1. So I'm literally writing minus. This is 1 minus 2 times 1. 2 times 1 is 2. And 1 minus 2 is negative 1. All right, we are moving on to continuing with exponents. And now we're going to get into scientific notation. We're going to simplify powers of expressions by using the properties of integer exponents. We are going to write a decimal number in scientific notation, and we are going to do some operations with decimal numbers by using scientific notation. All right, this is another reminder of the exponent rules that we're using. If you don't have an exponent, it's raised to the exponent of 1. Anything raised to the 0 power is 1. You know the product rule, they have the same base, you add them. The quotient rule, if they have the same base, you subtract the exponents. Negative exponents flip, whatever it has a negative exponent, it flips it either down to the denominator, or if it's in the denominator, it flips it up to the numerator. All right, so this lesson, I'm introducing you to the power. It's basically called power to a power. So here you see a is to the m exponent, but then that whole thing is raised to the n power. Well, if you have a power raised to a power, you're going to multiply those two numbers. For example, if you have x to the second raised to the third power, that's the same as saying x squared times x squared times x squared. Well, the exponent, if they're being multiplied, the product rule is you add their exponents. 2 plus 2 plus 2 is 6. Or now we have a power to a power rule, which says that you multiply those two exponents, and 2 times 3 is 6. So either way you want to think about it, that's what we're doing right there. All right, so going on to example 1, letter A, we have x squared raised to the power of 4. So the power rule says you multiply the two exponents when it's power raised to a power. So 2 times 4 is 8. Letter B, 5 times negative 2 is negative 10. Now it's never considered simplified unless you have positive exponents. So the only way to make that a positive 10 is to drop this whole thing down to the denominator. The exponent goes away. I'm sorry, the negative sign goes away. And you can't leave blank on the top, so you have to put a 1. Letter C, you're going to multiply negative 7 times 2. So negative 7 times 2 is negative 14. Once again, in order to get rid of that negative sign, you flip it down to the bottom. And 1 has to go on the top. So 1 over y to the 14th. Letter D, we have 2 to the third power raised to the negative second. And once again, on this problem, you can put it right in your calculator because it's a number. These, you won't be able to do that because they're exponents. They're not exponents, they're variables. So anyway, we're going to start out using our power to a power rule. So 3 times negative 2 is negative 6. So we're going to flip that down to the bottom. And since that's a number, we can actually figure out what is 2 to the 6 in our calculator. So 2 raised to the 6, I think we did this earlier and got 64. Yep, look, we did the same thing twice. All right, but let me also show you it's 1 over 64. Or if you use your calculator, we can plug the original problem right into our calculator the way we see it, and it should give us our answer. So we're going to put in parentheses 2 raised to the third power in parentheses. Uh-oh, I did it wrong. Do you see my parenthesis is still too small? So I didn't right click. Let me start over. I'm going to do my parentheses 2 raised to the third. Now I have to right click, get my parentheses down, in parentheses, and now I'm going to raise that to the negative second. Make sure you use your negative sign, not your subtraction sign. So raise to the negative 2. And then when I hit enter, it tells me my answer is 1 over 64, which is what I got right there. So the calculator is awesome. If you will use it whenever you can, it'll keep things easy for you. All right, another way we use the power to a power is if you have something like this. Now this is a times b raised to the n power. So make sure it's almost like we have to use the distributive property. We have to multiply every single exponent by this n. Well, if you don't see an exponent, it's 1. So that a is the same thing as saying a to the first times b to the first. Well, then n times 1 is n. N times 1 is n. So the answer is not just abn, it's an times b raised to the n. All right, so a lot of people want to just say, okay, the answer is 5x squared, but this is a multiplication problem, 5 times x. Well, 5 has an invisible 1 right there, and x has an invisible 1. So we're going to multiply every exponent inside the parentheses by 2. Well, 2 times 1 is 2. So when we distribute that 2, we get 5 squared times x squared. Well, we can simplify that because we can square 5. So 5 times 5 is 25x squared. Now we have simplified that problem. Letter B, we have 1s. We have 2 invisible 1s. So x raised to the third power is x to the third. And then y raised to the third power is y third. That's our final answer. Letter C, now ignore those 2 variables for a second. So basically this would be negative 7 squared, right? So negative 7 times negative 7 is positive 49. Because at first we'd have negative 7 squared, because you got to think of that in parentheses. That a has an invisible 1 right there. 1 times 2 is 2. And that b has an invisible 1. 1 times 2 is 2. So if I simplify this, I get 49a squared b squared. And that's my final answer. Letter D, don't forget your invisible 1s. So I would have a to the negative 5th times b to the negative 5th. Well, I have 2 numbers that both have a negative exponent. So I'm going to flip this down to the denominator, both of them. So I'd have 1 over a to the 5th times b to the 5th. And when I flip it over the line, I get to drop the negative sign. All right, letter E, I'm going to multiply every exponent by 4. So when I write this out, I get x to the 2 times 4 is 8. Negative 3 times 4 is negative 12. Well, now do I have to flip both of them down to the bottom? Nope, just the y, because only the y has a negative exponent. So the x, since it has a positive exponent, it stays in the numerator. The y drops to the denominator. And now I have simplified that. All right, I have a special note about negative exponents, negative numbers, and exponents. In the expressions such as negative x squared, we know that negative 1 is understood to be the coefficient of x. So basically, this is not in parentheses. So basically, the way this is written, it's negative 1, or what is the opposite of x squared. So it's just reminding you that if it's not in parentheses, that's what it's saying. It's saying, what is the opposite of 7 squared? Well, 7 squared is 49. The opposite of 49 is negative 49. However, if it was written in parentheses, -7 times -7 is positive 49. So you just got to be careful about those parentheses. Okay. So now we're going to look at letter A under example 3. Even just like we did earlier, whether they're being multiplied or divided, you have to distribute that 5 to every single exponent. So here we have an exponent of 1. Here's an exponent of 1. So 5 times 1 is 5. 5 times 1 is 5. And there's nothing else we can do to that. Letter B, we have that invisible 1. Well, 1 times 4 is 4. So 2 to the 4th over, there's an invisible 1. 1 times 4 is 4. Is that finished? Nope, because we can multiply 2 times 2 times 2 times 2. So that would be 16 over a to the 4th. All right, so now we're going to distribute that 3 to everything in the parentheses. I'm going to put 1s here so I don't forget them. So -2 raised to the power of 1. 1 times 3 is 3, and this is in parentheses, so let's make sure we write that. 1 times 3 is 3 over 2 times 3 is 6. Oh, wait, hold on. Y to the 6, excuse me. All right, so now we can say what is what is -2 times -2, which is positive 4, and positive 4 times -2 is -8. So -8 times x to the 3rd, y to the 6th. That's our final answer. Letter B, now it can get quite long. If you don't see an exponent, automatically put a 1 there. So you can remember that every single number and variable gets multiplied by 2. All right, so 1 times 2 is 2, so that's 3 squared. 2 times 2 is 4. 2 times 1 is 2. On the bottom, we have 3 times 2 is 6, and we have 2 times 2 is 4. All right, so we got quite a few things going on here. So first of all, we can simplify 3 squared. We get 9. Now our A's, we have 1 on the top and 1 on the bottom. So if we wrote out 4 A's on the top and 6 on the bottom, we could cancel out 4 pairs of A's. And wouldn't we have 2 A's left on the bottom? The quotient rule says we subtract those exponents. So the difference in 4 and 6 is 2. Since we have more A's on the bottom, those 2 A's would be left in the bottom. Same thing with our B's. We have 2 B's on the top. We'd have 4 on the bottom. We'd cancel out 2 pairs. And wouldn't there be 2 B's left on the bottom as well? The difference in 4 and 2 is 2, which means there has to be either 2 B's left on the top or 2 B's in the bottom. Since we have more B's on the bottom, that means they stay on the bottom. And that's our answer. All right, now example 5, that's a negative exponent. We need to go ahead and distribute that. We're going to multiply all of our exponents by -4. So 4 times 3 is -12. And then 4 times 5 is -20. Well, the only way to get rid of those negative exponents is to flip this one to the bottom, flip this to the top, and when you flip them, the negative signs go away. And now that's simplified. Now this is a great big multiplication problem. So the first thing we need to do is go ahead and get rid of those numbers on the outside. This is a mean problem. So first thing we're going to do is go ahead and distribute that -2 to everything in this set of parentheses, and go ahead and distribute that -1 to everything inside of this set of parentheses. So here we go. So we're going to do 2. 1 times negative 2 is negative 2. X to the 2 times negative 2 is negative 4. Y to the negative 6 over 3 to the negative second, because there's a 1 right there. There's a 1 right there. 1 times negative 2 is negative 2. Negative 2 times negative 2 is positive 4. And that's the whole first set of parentheses. All right, the second parentheses, we're multiplying everything by negative 1. Well, multiplying everything by negative 1 is going to give us an opposite sign of our existing exponent. So this is a positive 1. 1 times negative 1 is negative 1. So that'll be 4 to the negative first. 2 times negative 1 is negative 2. Negative 1 times negative 1 is positive 1 over 3 times negative 1 is negative 1. I'm sorry, I'm not multiplying 3 times negative 1. I'm multiplying 1 times negative 1. Negative 5 times negative 1 is positive 5. And 3 times negative 1 is negative 3. All right, I'm just going to look over this and make sure I did it right. Okay, so now we want to flip things that have a negative exponent. So that's what we're going to do next. We're going to get rid of our negative exponents. So this has a negative exponent. So on the first one, we're going to flip that 2 down, 2 squared. Well, below it, 3 is raised to a negative exponent, so we're going to raise that up. Our x right here, we're going to flip it down. This x, we're going to flip it up. This y, we're going to flip it down. And then look at this y right here. It is not raised to a negative exponent, so it actually stays down here on the bottom. All right, so all we've done so far is we've flipped everything to the opposite side of the line that had a negative exponent. So 2 squared came down, 3 squared came up, x to the 4th came down, x squared came up, y to the 6th came down, and since that has a positive exponent, it stays where it is. Now we're going to do the same thing with the second set of parentheses. 4 to the negative first goes down, and 4 to the first is just 4, so I'm dropping that positive 1 now. 3 to the negative first comes up, 3 to the first is just 3. This has a negative exponent, so it's going to fall down here on the bottom. Now this x does not have a negative exponent, so it stays in the denominator. That y is raised to a positive exponent, so it stays up here. And this one that's in the bottom, to get rid of that negative sign, you have to flip it up. So it's going to come up here next to this one. Okay, now let's simplify as much as we can. So 3 squared is 9. 2 squared is 4. All right. Now, these, we can go ahead and subtract those. They're together, right? Ignore everything else. So 2, these are being divided. So the rule is to subtract their exponents. So the difference in 2 and 4 is positive, or excuse me, the difference is 2. Well, is there more x's on top or more x's on bottom? So if we wrote out 2 of these x's and 4 x's on the bottom, we'd cancel out 2 pairs. And wouldn't there be 2 x's left on the bottom? All right, so I'm going to mark these off as we get rid of them. So we have dealt with 3 squared. We've dealt with 4, 2 squared. We've dealt with all of these x's. Now, these are being multiplied. It doesn't matter that they're in the denominator. They're being multiplied. So the rule says if you multiply 2 numbers that have the same base, you add their exponents. So 6 plus 4 is 10. Dealt with both of those. So I'm done dealing right now with the first set of parentheses. Now I'm going to do the second set of parentheses. Well, 3 to the first is 3. Well, these are being multiplied together. and they have the same base. So the directions say to add their exponents. 1 plus 3 is 4. All right, same thing down here. 4 to the first power is just 4. These are being multiplied. The rule says if they have the same base, they're being multiplied, you add their exponents. 2 plus 5 is 7. Okay, so we dealt with all that. Now, the last thing we do is multiply this big fraction times this big fraction. So we're going to multiply straight across. So the only thing, remember, you can not only, you can simplify up and down, but also diagonally. So right now, do you see that there are 4? Well, anyway, let's just go ahead and multiply straight across exactly like we see things. So these are coefficients, so I multiply those together. So 9 times 3 is 27. And what else do we have on the top? Y to the 4th. Over, here we're multiplying 4 times 4. So 4 times 4 is 16. We're multiplying these two x's. So two numbers that have the same base, you add their exponents. So 2 plus 7 is 9. And then what else do we have on the bottom? We have y to the 10th. We're almost done. The only thing we can do right now is simplify these y's. So we have 4 y's across the top, 10 across the bottom. Since they're being divided, the rule says we find the difference, we subtract them. So the difference in 4 and 10 is 6. So is there 6 on the bottom or there's 6 left on the top? Well, there's more y's on the bottom, which means when we find the difference of these two numbers, our y has to stay in the bottom. So 27, we cancel out all 4 of these y's because I have 10 on the bottom, right? So I don't have any more y's on the top. If I wrote that out, I would show that I've marked out all my y's on the top. 16 in the denominator, I have nothing to do with those x's, so I write them all out. So if we had 4 on top, 10 y's on the bottom, we cancel out 4 pairs. That means we still have 6 y's left in the denominator. Now, I was double checking, can you simplify 27 and 16? Is there anything you can divide 27 and 16 by? And the answer is no. So we are finished with that section.